Hey everybody, Cole here with Classic Mini DIY, and on today's episode we are going to be kicking off the first of a multi-part series on how to wire and create your own custom wiring loom for your Classic Mini. So you won't want to miss it. Stay tuned for that. All right, welcome to the next episode of Classic Mini DIY. On today's episode, we are going to be starting the process of creating and planning out the custom wiring harness that I'm going to be using in my Mini. Now, this is going to be a multi-part episode that I am going to be running in a long form style. This is going to be similar to my gearbox videos where you have chapter markers along the bottom of the video, which you can choose and skim to find the thing that you're most interested in. I'm going to be covering some basic electrical concepts as well as some primary things that you'll want to know when using a Haltech system, but also just in general when you're working on your own Classic Mini. Now, before we get started and get into the wiring aspect of this, many of you guys know that in previous episodes, I have shared and provided base maps for my ECUs that I have worked on in the past, and I sell base maps for Emerald, Speeduino, Haltech, DTA Fast. All of those are available on my store. But some of you may not know that those are a pay-what-you-want model, which means that I do offer those for free for those of you who maybe can't afford to purchase them. And the reason I do that is because this channel is about sharing knowledge. I want things to be more accessible and easier for any person to work on their car. And charging a crazy amount for a base map is not really in keeping with that plan. So I wanted to bring that up because I am going to be doing something similar with this wiring system. I'm going to be providing a wiring diagram that I'm going to build in conjunction with one of my lovely patrons. You might remember him. He has an orange Mini who got my fast road engine that I built. His name's Kenny. He is going to be helping me map out and create a really awesome wiring diagram. That will also be a pay-what-you-want model, but it will cover how everything that I am going to be covering in these videos gets connected and wired in together. Additionally, there will be a base map that I'm going to provide for the Nexus R3. This is going to be focused on the setup that I have, which is with this whole custom wiring harness, but it will include a base fuel map, ignition map, and of course, this is a drive-by-wire setup that I'm going to be running, so I'm going to have a drive-by-wire map, NOx sensors, all sorts of really great stuff to get you started on your build, should you want to do that on your car. So if you feel like you want to support the channel or you want to support these types of videos in the future, please consider purchasing that map or that wiring diagram once it becomes available, or heading over to the store and picking up something else that maybe you find pretty cool. Maybe some merch, a shirt, a hat, or some of the really cool OEM Plus parts that we sell direct from wonderful vendors all over the world. Before we get started on covering what these wires do, how they're going to be connected, and all of the various different things, let's talk about briefly the hardware that we're going to be using so that you guys have an understanding of how I'm going to be mapping this and how it might be in relation to maybe a more stock setup, or if you're going to use something similar to what I'm doing, which is a Haltech ECU and a power distribution module. Okay, so as you can see here, I've got a few things laid out on my table, but the core items and the things that I want to cover for you guys briefly, because I have done an in-depth video on these items in the past, which I'll show up in the corner here. But what we're going to be using in my car is a combination of a few different things to fully modernize the electrical system. Now, the brains and the core of this operation is the Haltech Nexus R3. This is a vehicle control unit, which is a little bit different than an ECU because it has the brains and the control to do all sorts of really cool things, which we will be installing in my Mini, such as cruise control, launch control, really awesome idle management with a drive-by-wire throttle body, and much more. In addition to doing all of those things, it does do power management as well. This has a built-in power distribution module. Now, a power distribution module you can think of like a sophisticated fuse box. Within the context of these ECUs and many ECUs that offer this type of system, it will fully replace the fuse box and relays within your car so that you can control all of it from single wires coming from the onboard computer instead of individual wires running all over the car. It simplifies things, it makes things more reliable, and it makes things more resilient to failure. Now, the power distribution module in this ECU is a little bit smaller than the one that they offer in their bigger VCU, which is the Nexus R5. The Nexus R5 is a really big, fully featured, incredible motorsport VCU. But this one is kind of a trimmed down model with many of the same features, just with a few less outputs. And so that, coupled with a device that I already had from my previous build, which is an individual power distribution module. This is the Haltech PD16. This is purely a power distribution system, and currently this unit can only be used in conjunction with a Haltech ECU or VCU. Just something worth noting. There are power distribution modules that if you don't plan to run a full ECU system, you can replace your fuse box and relays and use just an individual power distribution system. Lots of different companies make those. I'll leave it to you guys to find them. But this has multiple outputs on it, and they vary in their capacity. Some are 25 amps, some are 8 amp. All of them are high current outputs, and there are some kind of more sophisticated outputs as well for some cool features. We'll get into all of that later on, but these are the two items that I'm going to be using together in order to fully control my car. Now, with that out of the way, I do want to talk about just some of the core principles of electricity and the way it works in a car. I think it's going to be really important to just remember these things in order to apply them to the construction of our wiring harness. Okay, so to start things off, I do want to briefly cover some principles related to 12-volt systems and how they apply to the Classic Mini. This is a very simplified version of the two different types of wiring systems in a Classic Mini, but it also will kind of encompass how electricity works within the context of a vehicle wiring system, a 12-volt wiring system with a DC current. Essentially, when you're wiring something, what a circuit wants to do, or what electricity rather wants to do, is complete the circuit. It wants to move from the positive side to the negative side of a battery, or the positive charge to a negative charge. This is kind of at the core of how electricity works from a physics perspective, and this is what we manipulate in order to make electrical devices work. So you can see here, we've got two different diagrams, and these little symbols here with these lines, those are your grounds. And the Classic Mini, as well as many other older vehicles, used to do something called a positive ground charging system. So you would have your positive side connected to the chassis of the car, which effectively makes your entire car a conductor of electricity. And then you'd run your negative leads to the various electrical devices. In this case, I have some rudimentary light bulbs drawn. And then when you ground that to the chassis of the car, you are completing that circuit, and that's when that light turns on. Now, we use the exact same principle in modern electrical systems. However, almost every modern car is using a negative ground instead of a positive ground. So in the new setup, and in any setup where you're going to be building your own custom wiring loom, unless you are just absolutely adamant about keeping the positive ground on a original Mini, you're going to be moving to a negative grounded system. And any of the electronics that we're using, and most of the electronics that you add to a car in this day and age, do in fact require a negative ground. So something to keep in mind depending on the application that you are working on. So let's get this old-fashioned method out of the way and talk purely about this new one here. Now, as you can see, we're doing the same thing where we're adding a positive lead to whatever device we want to power. And then when we are completing the circuit by connecting it to the chassis of the car, it's allowing the current to run through the car and back to that battery negative terminal, and thus completing the circuit. We are going to be applying this methodology to the majority of the circuits within our new setup and our new wiring harness. There is some complexity in some of the circuits that we're going to be creating. how they are going to be creating their ground, where the signal is going to be going, all sorts of different things, which we will get into when we create each individual circuit. But there are some really excellent deep dives into automotive electricity that I would strongly recommend checking out. Those will be popping up in the corner if you feel like you need to look those up and learn about them. Okay, so now that we have kind of the basics of electricity and how that works in a car, kind of just briefly talked about, let's go over the different type of circuits that are available to us with the Haltech setup that we're going to be running. And then we're going to get into applying those individual circuits. I'll give you guys a few examples of how to wire some of these things up so that you can apply it across all of the electrical devices in your Mini. Now, with most modern ECUs and with most modern wiring systems, you're going to see some commonality in the types of circuits you can attach to them. In older Minis, like the ones that we have, most of our circuits are simply just 12-volt signals or lower voltage signals that go to things like the fuel gauge sender or some of these really older like voltage regulators that manage the generator on your engine. But for the most part, a classic Mini has pretty basic circuits, 12 volts or 0 volts. You either have something on or off for almost every circuit in your car. Doesn't matter what it is, whether it's headlights, turn signals, high beams, radio, heater, wipers, it's all very binary, on or off. With a modern ECU, you are provided the ability to do more complex things with your circuits. And with complexity, you also get a lot of benefits and the ability to do some pretty cool things like cruise control, managing your headlight turn signals, all of those different things, all through your ECU. And so since we're building a loom from scratch, we are going to take advantage of a lot of those things. And it's important to learn the different types of circuits that you can have with your ECU and what each individual one does. So we have about 14 different types of wires, and I'm going to go through all of those. It sounds like a lot, but let's break them down into their base functions and what they might do in your car. Now, to start off, let's talk about the simplest and the kind of primary wiring type, and that is your high current output. That's a HCO. These are your primary power circuits, things that you would be powering switches with, that you might power gauges, you could power your horn, your fuel pump, basically any 12-volt circuit. The ones that I was just talking about, which were your simplest, most basic circuits in your classic Mini, those are going to be the ones that you will wire and control through the HCO circuits. These can be either 8 amp or 25 amp. There are a few of each of those, and depending on the device that you're trying to power, you will choose the amperage that's necessary. If you think about the devices in your modern car, if you have one, things like a horn might have a 10 amp fuse or a 5 amp fuse because it's a very low power circuit. But then maybe your heater or your AC compressor might have something like a 25 amp fuse in it. So those are where those things kind of vary and how you might apply those to individual circuits in your car. Next up, we have a half bridge output. This is a very sophisticated output that is made specifically for controlling complex devices. So in our case, and what we're going to be using them for in our car, is to manage things like the drive-by-wire motors and the throttle position sensors. All of those we'll get into when we start to install those in the car. Next up, we have an analog voltage input. This is also a pretty sophisticated input that allows you to use things and run signals into the ECU. So you have things like maybe your rocker switches. If you want to have a very basic on-off toggle, you can wire those to the original factory switches. You can send your sensor feeds into this. Things like your coolant temp sensor, your air temp sensor, oil pressure, all of these different types of sensors can be run into your analog voltage inputs. Next, we have a synchronized pulse input. This is for more complex sensors. So think of things like your tachometer, your vehicle speed, or things like your camshaft or crankshaft trigger sensors. These are sensors that manage and send a square wave, allowing you to measure the frequency that something is occurring. So it's perfect for something like a vehicle speed sensor where you have something rotating and then it measures how many times that item rotates, which is the frequency of its rotation. That gets sent into the ECU, interpreted as your speed signal, and then you can use it for all sorts of really exciting stuff. Next up, we have the digital pulsed output. This is for more complex electrical devices that you would need to run pulses or steppers. So things like a boost controller, relays, things that you might need to pulse and change the frequency or change the amount of voltage at a high rate of speed. The most likely thing that you are going to be using this for is a boost controller, which will manage, of course, your boost if you have a turbocharged or supercharged engine. Now, we talked about the analog voltage input, but next we have the 5-volt sensor feeds. Now, this is pure power in the form of a 5-volt signal. Most modern sensors use a lower voltage than the full 12 volts available to them. So things like your air temp sensor or your oil pressure sensor, those might require a 5-volt feed instead of a full 12-volt feed. These are all available in the ECU. The ECU has a wonderful power output for those 5-volt items. And if you buy the full wiring harness loom that comes with it, those will come pinned out and ready for use. Next up, we have sensor grounds. This is a little bit different than the ground I showed you for the chassis ground. The sensor grounds are a fully conditioned ground that you are running into the ECU. So your ECU is grounded to the chassis and the battery like you would normally have it. But the sensors will be grounded inside the ECU, and that provides a very clean signal for them so that they don't get any sort of interference. And it's very important to run any sensors into that ground, not into a chassis ground. Next up is your primary ground. This is your chassis ground, which I was just talking about. And this is where things that don't get impacted by signal degradation or anything like that, just require pure power, can be grounded to. So like a headlight would be grounded directly to the chassis that they would run back to the battery. Now getting into some of the more specialized items that come with the R3, but also most modern ECUs. First up is your shielded wires. These are often a collection of multiple wires, types that we've just talked about, but in reference to the Haltech setup, these are shielded and set up, made to prevent any sort of interference, and they are often used for things like your crank trigger, your cam sensor, or knock sensors, which will also be running in this car. Next up is your wideband wire. This is available via an onboard wideband controller. This measures your air-fuel ratio, and on the R3, it has a controller built into it, so you can plug that sensor directly into your ECU. Next up is the power feed and the specific lines for your injectors. The Nexus R3 has the ability to run up to 8 injectors. And as we talked about before, there are many different wiring types, but the cool thing about the unused injector wires, so in our case, obviously the Mini doesn't use 8 injectors, those extra ones can be digital pulsed outputs, or they can be switch inputs. So you can attach them to rocker switches or other things like a brake switch or a clutch switch. Then moving on to a similar wire are ignition wires that manage the actual firing of our spark plugs. We're going to be using a wasted spark style trigger system, which is going to fire our spark plugs in our specific order. But as a result, we will have a surplus of ignition leads as well. And those are just like the injectors. You can use them for a digital pulsed output or a switched input, which we'll probably end up using throughout the car somewhere. Now, it is important to note that the Haltech ECUs do not have a built-in igniter. That is a special unit that charges up the power used to fire your spark plugs. There are many coil packs that have those igniters built into them. I will link one in the description below if that's something that you're looking for. It's important to note because if you have a coil pack that doesn't have one of those built in, you're going to need to add one and configure that with the ECU. Now, the final wire that we have is something called a CAN bus wire. You can think of this kind of like a network cable that runs between your different devices. It's a very sophisticated type of wire that allows communication along a 12-volt system. So your devices like your Nexus R3 and PD16 can communicate with each other and operate independently, but also in conjunction with each other. The CAN wires can be used for all sorts of really cool things. Things like a CAN dash, which is an LCD dash that Haltech sells. There are CAN keypads. There's all sorts of different things that you can apply to the CAN network. And it simplifies your wiring quite a bit, as well as the configuration of those devices. You can see here that I'm also going to be installing what's called a CAN hub. This is going to allow the extension of the CAN network in a pretty easy way. This allows me to plug things in. So if I want to add a display in the future, or if I want to add a keypad, I can simply plug it into this hub and it's going to automatically get picked up by the rest of the CAN network, and then you'll be able to configure that in the ECU. So at a high level, that is the circuits that are available on the Haltech wiring looms that you might purchase with these ECUs. Now, if you're not using a Haltech ECU, that's totally fine. Those wiring types are often pretty universal across aftermarket ECUs, whether you're using one from ECU Master, Emerald, DTA. The concepts are the same. They might have slightly different names, but the functions of those wires are going to remain pretty similar. In my experience so far, Haltech has had the most user-friendly method for configuring these. Their software is extremely easy to use and to pick up. A lot of people think if I get an ECU, I'm going to have to be some programming wizard. I'm going to have to know all of these things. And while you will need to spend a little bit of time getting used to the software, it's like a full visual interface with drop-down menus, pretty clear understanding of where you're changing settings and things of that nature. So don't worry too much if you're not super tech savvy. This stuff is made to be accessible by lots of people. And in my opinion, despite Haltech being more expensive than some of the other brands that are out there, there is a reason, and that's because they have excellent support. You can call them for just about anything, and their software is super, super easy to use. So with that out of the way, let's talk about some of the circuits that we're going to be running in the Classic Mini and how we're going to be attaching them to this wiring harness, so you guys can get a few examples of how I'm going to be doing that in my car. Now to begin, I want to do a relatively simple type of sensor, and this is an analog voltage. That's just a voltage-based sensor. Now, the sensor that I'm using in this reference is a fuel pressure sensor. You can see this is my Aeromotive fuel pressure regulator. This is my rising rate fuel pressure regulator, which allows the rate of fuel pressure to increase as the boost is increasing so that it can be accommodated for when I am spinning up the turbo and adding more boost and more pressure to my intake system. Now, if you don't want to run a sensor like this, or maybe your ECU doesn't have enough inputs to do this, you can always use a mechanical style gauge, which would go right on in the same hole on this specific fuel pressure regulator. This little gauge would allow you to set your base pressure when you are setting up your car and setting up your fuel injection system. This is actually what I used prior to running my own fuel pressure electronic sensor. Now, wiring this in might seem complicated and might seem like it's going to be very difficult, but the reality of it is that it is purely a voltage-based sensor. So each sensor is going to come with its own voltage scale. This is usually provided by the supplier or by the company that you purchased a sensor from. If the supplier is not able to provide that for you, I would not purchase the sensor from them. It's very important because if you don't have that scale, your ECU won't know what the actual pressure reading is at various different voltages. Now, when we get to the configuration step of the ECU, I'll show you a little bit more about how that works. But for today, I'm going to focus purely on wiring in the sensor and how you would do it on your car. Okay, to start off, we are looking at one of the AVI, that's the analog voltage input branches that's already come pre-wired in your Haltech Flying Lead loom here. This will come with all of the wires you need for the amount of AVI inputs that are on this branch. So this branch of wires has just 2 inputs on it, but the wires are consistent across any other branch of your AVIs that you might need. And the wires that are included are an orange 5-volt feed. This is just purely 5-volt power being fed. A sensor ground. This is one of the conditioned grounds that we talked about before. And then your sensor feed. Now, depending on the sensor that you are wiring, you may need all of these. You may need a different type of power. There's lots of different scenarios that you can run into. But for this sensor that I have on my pressure regulator, this is a 3-wire sensor, which means that it also has a power, ground, and signal line. And then this sensor requires a 5-volt feed, which means we will be wiring our orange 5-volt feed into the feed for power here, which is the red wire on the sensor. we will be wiring in a sensor ground into the ground circuit on this sensor. And then finally, we will be choosing one of the two wires here to be our sensor feed, and that's what goes up to the ECU. And this wire is the one that you're going to want to take note of the color so that you can configure this by choosing it in the drop-down menu on the Haltech software, saying this is my fuel pressure sensor, and that will get wired in there. Now, I'm not going to crimp these wires right now because I don't want to wire anything into a circuit until I have my car here and I can start running these wires out to where they might need to go. But from a wiring perspective, this is how you're going to wire in your 3-wire analog voltage sensors. That's sensors that measure their signal based on resistance or on voltage. So, feels like a lot. If any of that doesn't make sense, post in the comment section. I'll do my best to answer. Now, switching gears a little bit, we are going to be doing an input and an output next. I figured it might be a good idea to pair these two together because they are similar and they are going to be feeding each other. And I'll show you what that means here in just a moment. But as you guys can see here, I have started mocking up the center panel of my Rally Dash. And I have to tell you guys, I am so excited about having this in the car. The cool thing about every gauge that you see here is that they are all digital gauges. They all have digital stepper motors in them, and all of their sensor feeds are electronic. We aren't using any sort of mechanical gauge up front. And the reason we're doing that is so that I can use modern sensors fed into the ECU, which will then be interpreted by the ECU and used by that software to do everything it needs to do. And then I can run outputs, generic outputs, to the sensor feeds on each of these gauges, which will allow these gauges to be run directly off the ECU. It's one of the coolest things that you can do on the Haltech setup, having your VCU, in our case the Nexus R3, controlling everything. Not only is it controlling the electricity in the car, not only is it controlling the injection system in the car, but it is also running all of your gauges and outputting a consistent feed that you have of data coming from the engine all the way to your gauges. So when you look at your gauges, you can be confident knowing that's also the information coming from your ECU. And that's pretty cool. And that's a lot of peace of mind. So to start off here, what we're going to be covering in this little segment is how to wire a synchronized pulse input, which in our case is going to be a speed sensor. You can see that this is one of the speed sensors that gets screwed directly onto the gearbox speedo output. So we won't have a physical cable going up to the gauge anymore, and we will be running this into one of our synchronized pulse inputs. The ECU will interpret that so it understands what speed you're at. And with a bit of math magic, the ECU can also determine which gear you're in based on your RPM and current speed using a gear ratio. Now, we'll cover all of that in the next episode during our programming, but it's something super cool that the ECU can do and will allow you to do lots of advanced features. So to start off, this sensor is a little bit different than our last sensor. Our last sensor required a 5-volt power feed. This one requires a 12-volt feed, which is fine, but it means that we won't be using the orange wire for our power feed coming off of this branch of wires for the synchronized pulse inputs. That said, the rest of the stuff is pretty much the same. You're going to take your sensor ground, one of your sensor grounds, connect it to the ground of this connector. You're going to take a 12-volt feed, so you're going to have to run its own power wire, a 12-volt power wire, to power this little fella. And then you are going to run your sensor feed, which you'll match up a color from the SPI input circuit here and wire that into the sensor feed, which will then be interpreted by your ECU. After you do that, there will be a little bit of calibration you have to do. A synchronized pulse input essentially is something that is spinning or something that is emitting a pulse at a specific frequency. And ultimately, when we configure this, we will need to know how many pulses or how many revolutions causing a pulse happen at any given speed. Now the ECU has some pretty cool calibration software. You can do that on the dyno, or you can do that while you're driving with a passenger helping you out. This information will feed the ECU and provide it the correct information for how fast you're going. Now, once you have that sensor wired in, the next step is to wire your generic output. Now, in the case of this Smith's digital gauge that we have here, it has the ability to configure how many pulses that we just talked about with the sensor it expects to see for every mile per hour. And that setting can be configured on your ECU, but it can also be configured on the speedometer itself. We will do that when we get to that stage, but the way that we wire this is pretty straightforward. So we are going to take one of our new DPO circuits. There are 6 of them here in this collection, and one of them is going to be our feed that goes into the sensor feed going into our speedometer here. Now, that's it. Once you've wired that into the sensor feed, your speedometer is ready to be configured and calibrated. Now, depending on the speedometer that you are using, that feed wire could be any number of colors, but at the core, you are going to be wiring it into its sensor feed. And as you are configuring these various other gauges, you're going to be doing similar things. For the speedometer, it requires a digital pulse output because it requires a certain amount of pulses to determine how fast the engine is going. The tachometer on your car is also going to be similar. However, on the Nexus R3, it has a dedicated feature that you would configure. You'd still have to wire a wire to it, but it has a little bit more prescriptive setup in order to wire a tach in your car. Now, some of these other gauges are a little bit simpler and will require a different kind of output. As you can see here, we have an oil pressure gauge and we have a water temperature gauge, as well as a boost gauge. Now, all of these gauges use a voltage or resistance to determine where that needle should be on the gauge itself. And that's part of scaling your sensors. The process I mentioned earlier, and it's just simply putting the values in for what it should expect at 0 volts and what it should expect at its highest voltage, whether it's 5 volts or 12 volts. We're gonna wire up our sensor feed just like we did before on the speedometer, but we're also going to be changing the table a little bit and what this gauge is expecting. Now, I know I've said this a few times, but I will be getting to those details in an upcoming video when we start to actually wire these inside the car, rather than showing you guys conceptually how it works on the table here. So I know that was a lot of information, and I think I'm going to wrap up part 1 of this video now because I don't want to overload you guys with a ton of information. There are so many more details I can add here or there, which I'm going to do my best to cover in all of my upcoming videos as we start to wire these things into the car and show you guys how it's actually being put in the car. But I am incredibly excited about this. I hope you guys found this helpful. I hope you found the type of video rewarding and informative enough. If you have any questions about the things that I covered in this episode, how I'm gonna run something, how I'm gonna wire something, please feel free to post it in the comment section below. I really wanna help you guys with this and help this kind of information become a little bit easier to digest and implement on any modern car. That said, don't forget, this is a journey. You aren't gonna learn all of this stuff overnight, and it's part of building out these cars and experimenting and making mistakes in order to do stuff like this. The beautiful thing about these ECUs, but also many of the ECUs in the market now, is that they are extremely fault tolerant and allow you to experiment and try all sorts of new things, even if you haven't done it before in the past. So thanks again, everybody, for joining. And until I see you on the next episode, I really appreciate you joining in, and you know the drill. Enjoy those minis and motor on. See you guys later.